Hello, hi guys, welcome back to my channel. Today we are going to dive into the fascinating world of Kubernetes and learn how to set up your own Kubernetes cluster on AWS using Terraform. Don't worry if you're new to this, we'll break it down step by step using simple examples and a touch of humor to keep things fun and engaging. So let's go ahead. What is Kubernetes? Imagine you are a software developer with a brilliant application that needs to be deployed and managed efficiently. Kubernetes is like having a team of magical employees that automates the deployment, scaling, and management of your application. But before we can enjoy the benefits of Kubernetes, we need to set up our own cluster. Let me give you a real life example to make it simple. Imagine you're running a busy coffee shop. You have hundred of orders coming in for different type of coffee, each requiring different ingredients, brewing times, and methods. Now, wouldn't it be great if you had a system that could manage all these orders for you? That's exactly what Kubernetes does, but for your software application instead of coffee orders. Kubernetes is an open source platform that automates the deployment, scaling, and management of containers applications. Containers are like coffee machines in your coffee shop. They hold everything an application needs to run. So Kubernetes makes sure these containers are running as expected and can scale up or down based on the demand, uh, just like Starbucks managing a coffee shop. So let's move on to our project. We are going to set up Kubernetes on AWS using Terraform. Uh, I already explained about Terraform in the previous video, and also the previous video is about creating VPC with EC2 instance using Terraform. So I highly suggest you to visit that video first and then come back here. That covers most of the details. Like you need to have a clear understanding about VPCs, subnet security groups, EC2 instances, IAM roles, and others to get started with this video. So let me show you a real example of Kubernetes. Yeah, here it is. Is this a Kubernetes documentation? So we have, so I'll just go ahead and show you the normal. So so this is the control panel, and I have diagram set up for you as well. So this is the previous diagrams which I used. So I created VPC, VPC and subnets, the private subnet and a route table and the internet gateway with IP address, and I have applied using Terraform, and I created access and secret keys, and I using the access keys and secret keys. I actually initiated the process, and I actually created the resources on the previous video. So coming to this video, so before we start, make sure you have an Amazon Web Service account. It's free account for 1 year, and Terraform installed on your local. That's the first thing. This is a, like as I explained, it's an infrastructure provisioning tool which we'll be using to define and deploy our AWS resources, and also basic knowledge of AWS resources. So in this video, we are going to create a VPC with two subnets spread across different availability zones, and we will be creating EC2 instances within the VPC, allowing SSH access, and setup of EKS cluster serving as a managed Kubernetes control panel, and configuration of IAM roles and policies for EKS cluster and worker nodes, and also creation of EKS node group with no worker nodes, usually like you usually provided using the subnets and security group. So this is the tabular form I created for you so that you can understand. So this is the resource types and names which we're going to create through our code. So before going to show you the code, let me explain you about what was the difference between the normal self-host managed Kubernetes and the AWS EKS. So let's talk about AWS EKS, which is called Elastic Kubernetes Service. Uh, like you using AWS EKS is like hiring a full service team to run your coffee shop. This team takes care of everything from managing the coffee shops, training the Starbucks team, managing the cleanup, and to ensure the coffee shop is open and ready to serve customers every day. Basically, you just need to pay for this service, and the resources associated with this, because we're going to create a different instance in order to connect to this AWS cluster. I mean the EKS cluster. Basically, we are going to use kubectl to connect to this cluster, and we are performing activities. We will be performing activities using kubectl once the cluster is created. In technical terms, AWS EKS is a managed service that makes it very easy for you to run Kubernetes on AWS without needing to install, operate, and maintain your own Kubernetes control panel or nodes. So AWS takes care of the underlying Kubernetes infrastructure, allowing you to focus on deploying and running applications. So actually, there is one more thing you need to make sure before doing this. AWS charges like 0.10 dollars per hour for each EKS cluster you create. I think this cost is for managed service itself and doesn't include the cost of worker nodes, and that would be more. And also, if you have any application related storage or any other resources used, they are billed separately based on their respective pricing. When it comes to the self-managed Kubernetes, running a self-managed Kubernetes is like running your own coffee shop entirely by yourself. You buy the coffee machines, hire and train the Starbucks team, and clean up the shop and make sure it's open and ready to serve customers every day. It's like more work, but you have complete control of your every aspect of your coffee shop. In technical terms, a self-managed Kubernetes means you need to set up and manage your own Kubernetes cluster. You're responsible for everything from setting up the control panel, like and adding worker nodes to upgrading and security the like securing the cluster. It gives you more control and flexibility, but also requires more effort and expertise to manage. So cost of self-managing Kubernetes would be like a cost of running self-managed Kubernetes on AWS primarily involves the cost of EC2 instances you use for control plane and worker nodes. The cost can vary widely depending on the instance type, number of instances, and how long you run them. There are no additional charges for Kubernetes itself as it's an open source platform. So comparison in terms of cost, AWS EKS has additional cost for the managed service, but it can save you time and effort in managing the Kubernetes infrastructure. On the other hand, a self-managed Kubernetes doesn't have this additional cost, but it might require more effort and potentially more resources, which could increase the cost in future. In terms of control and flexibility, a self-managed Kubernetes gives you more control over Kubernetes configuration and allows you to customize it to your needs. AWS EKS, which is like less flexible, provides a stable and standard environment that's easy to use and manage. I would suggest if you have a very less team in your business, I think you can go for AWS EKS, and if anyone doesn't know anything about it, and if you have any expertise in your team, and if you maintain huge team, I don't suggest using EKS. You should use self-managed Kubernetes. Let's dive into uh, the main plot here. Like I'm going to um, create Kubernetes cluster on AWS using Terraform in this video. So this is the high level architecture of it. Like we're going to create VPCs, subnet, two subnets, and route table and associate route tables and internet gateway. And we're going to create cluster node which has master, and we are going to create IAM roles, and we have provided two policies and also security group with ingress and egress rule, which will be mainly consist of opening in and out traffic. And also in we will be creating EKS node group which has worker node and IAM roles which has like three policies. So here is the diagram which you can look at. Actually, the kubectl will be responsible. We'll be creating kubectl. Once we create the cluster, we'll be installing the kubectl in your EC2 instances where you create the cluster, which has the cluster, which are part of the cluster basically, and then this is how it works. And this EKS control plane will be managed by AWS itself, so you don't need to worry about it. You just need to create managed nodes, and then the load balancer and application will be used by the load balancer and something like that. And I have created a flowchart for this. This is the code which I'm going to work on. I just defined very easy steps so that you can understand it better. So we are going to create, we already have a AWS account and I installed Terraform on my local, and we also have an understanding about AWS concepts, which are like more of VPC, subnets, security groups, EC2 instances, IAM roles, and such. And this is something like if Terraform does, we once the code is up, is ready, we're going to initialize the Terraform code to make sure to install the AWS plugins and then plan for the deployment and see what resources are going to be created, and then apply. Once everything is valid and successful, we're going to apply it. So what we are going to create in this video, so create VPC and create two subnets and create internet gateway and route table and association route table and create service now security groups and create EIP, which is called elastic IP address, and the instance and IAM roles, and we will be attaching those IAM policies and create policies and creating IAM instances profile basically, and then create EKS cluster and create EKS node group. So let's go ahead and dive in and I'll show you the code which I have worked on. Yeah, here it is. So let me explain each one by one real quick. So the EKS, this is the EKS folder. I created two folders to make sure it will be very easy to understand. This is EKS and this is security groups for EKS. If you remember in the previous video, we have created VPC with EC2. So there are additional parts which I have added here, which is I have added the second subnet. I have only created one subnet in the previous video, so I'm creating a new subnet here, and then and also there are only one associate subnet which with root table which I created, so we need two here. So I created second one. I named it as 2, and then I have added modules for these two folders, sd underscore EKS and EKS, right? So I have provided the modules which are like providing the EKS VPC ID with the name, and then this. So this we got this from. Let me go back and so this is where, if you go to the variables, I have mentioned for. So this is this EKS.tf file. Let me explain about this EKS.tf file. So this file contains the Terraform configuration for creating Amazon EKS cluster and an EKS node group. It defines the IAM roles, policies, attachment required for EKS cluster and worker nodes. And it also simplifies the cluster VPC configuration such as subnet IDs and security groups. So this is the resource which I am creating. This is a master, and which I assume for all role policy, and I am creating these policies like Amazon EKS cluster policy, which is this this IAM policy grants permission necessary for managing a EKS cluster. So it includes permission to create, delete, and describe clusters, as well as managing tags and updating cluster configuration. And the second one would be Amazon EKS service policy. This policy, this IAM policy grants permission for EKS service to perform actions on your behalf. It includes permissions for service linked roles such as managing elastic load balancers and Amazon VPC resources. And the next one would be Amazon EKS um, VPC resource controller. This IAM policy provides permission for Amazon EKS VPC resource controller to manage and associate elastic network interfaces (ENIs) with worker nodes in the cluster. It allows the VPC resource controller to manage networking resources effectively. So that's why we need this role. And when you go to resource, and we provide it as a worker name, and this has so this has the autoscaler. So autoscaler is this IAM policy provides permissions for managing autoscaling activities in Amazon EKS clusters. It includes permissions to describe, scale, and manage autoscaling groups associated with the EK cluster. So that's why we use this, and this is so also I think there is one more. There are two more parts. Yeah, I think EKS Amazon EKS worker node policy. So this IAM policy grants permission necessary for worker nodes in EKS cluster. It includes permission to access EKS APIs interact with auto scaling groups, manage instant profiles, and perform other worker node related activities. And the next one would be EKS CNA policy. This policy provides permission required by AWS Control Network Interface plugin. So this particular plugin actually, which will be dealing as a like permission to provide permissions to create and manage network like interfaces, IP addresses, and route tables in the VPC. And the next one would be Amazon has managed instance code. So this grants permission for EC2 instances to communicate with the system manager, AWS system manager. It allows EC2 instance to execute commands, retrieve configuration data, and enable management features provided by SSM. And the next one would be registry read-only. So I think this IAM policy provides read-only access to Elastic Container Registry. It's basically specify role to pull the container images from ECR repositories. So basically, I'm going to talk about container. It's simply you can think of it as it's a place where you deploy application. But I'm going to do a separate video for containers and Docker containers and how we maintain them. And that would be useful. That needs a different video for that, so I'm going to do that. So X-ray. Okay, so this is main actually. This is like most of the production servers will be using this. So this provides permission for X-ray service. This includes permissions to collect and upload tracing data, access trace data insights, and perform other actions related to X-ray. And the last one would be S3. It's a bucket name. So it actually this is the Amazon S3, which is nothing but simple storage service. This grants read-only access to Amazon S3. So it allows the specified IAM role to read objects and list buckets in S3. So I already spoke about autoscaler. This actually permissions to describe, scale, and manage autoscaling groups, so that whenever there is any deletion or anything happened as such, it will automatically like scale and manage like scale and manage the resources basically. And yeah, these IAM rules or policies are defined to use the necessary permission for different components and services involved in Amazon EKS cluster. They ensure that the cluster, worker nodes, networking, container registers, and other related resources have the appropriate access and capabilities to function properly within the EKS environment. So yeah, so and this is next when you come to here, I think this is the resource. We are creating the cluster and the cluster name, and we provided all the dependencies. If you remember, I have explained about depends on meta argument. This is kind of we this cluster will always depend will check for these roles has been created or not. If not, it will throw out an error that these are not created. And finally, EKS node group. So as I explained, so here we are going to provide the cluster name. The resource is AWS EKS node group, and the name is node backend. I just gave it something like that. And cluster name and node group name I just mentioned is as dev, and the node group, this is the something the normal worker role. And we are providing two subnets here because we have created two subnets. We'll be creating two subnets in this, so that's why I have mentioned here, so that the node group will be using that. And capacity on demand, and here we are giving the disk space as 20 GB and T2 micro. Oh, I think we need to provide small here, but let me, because EKS needs to have a similar, like it can't accept micro because it's very less CPU. So at least you need to provide small instance type, AMI type. And uh, yep, and the remote access, we're providing the EC2 SSH access as well. This is because once we'll be able to create, if you want to access the node group or anything like access the EC2 instance, you need to have create. So this I'm using the same demo 3 which I used in the previous document, in the previous video. And there's a scaling group. Desired is 2, maximum is 3, and minimum size is 1. So I think it will create 3 instances because we provided maximum as 3. and maximum enable would be 1. And this node group depends on these three. So if you see here, all the roles which I created, so these are all depends on EKS cluster. These roles has to be there for EKS cluster, and these roles has to be there for EKS and node group. And I provided the variables. This basically okay, this is output. We are just providing the EKS endpoint after creation, after the cluster creation, and the variables would be SGIDs, and I provided SGIDs and then subnet IDs and VPC ID. And let's go to the security group. Security group, we just provided worker node, and yeah, these are ingress and egress. If you go back to the diagram which I showed you, uh, yeah, here it is, security group and ingress and egress rule. That's how it is. And yeah, for variable I provided VPC ID as a string, and that's it. So I think we covered everything. Let's run the code and see how it goes. We'll just do Terraform init, and then Terraform validate. Let's see if there is any issues. Okay, Terraform plan to see what resources is going to create it. Okay, there are 27 resources has to be added. Let's go and see what it's trying to create real quick. So it's going to create the elastic IPs, and the kubectl server will be created, which is AWS instance, and the internet gateway, and the route table, and association two route tables, and VPC, and it has subnet, one subnet, and the subnet 2, and kubectl VPC. The second the VPC, and then the cluster, and the node group. So that's how it creates, and finally it creates the profile, instance profile worker node. Okay. Yep, I think we are good. Let's run this. And also, okay, there it created autoscaler as well. See, worker node profile, autoscaler, and master node profile. Okay. It's going to create. Okay, and then the roles, policies, which is has to be created. So these will all be created through autoscaler S3 X-ray. So it's pretty much covered everything we just went through. So let's go back and see real quick. In our AWS dashboard, we are in AP. We are using AP South 1 here. So let's do it. Yeah, there are no instance running, and the default is running right now in, yeah, these are all default. So right now the all the VPC subnets, there are no subnets, the route tables, internet, these are default actually. If you go in here, so this is the default VPC which is running, so you don't need to worry about it. And then yeah, and there is no cluster added as of now in this region, if you see. Okay, let's go ahead and run the code now. Terraform. Okay. You type S. Okay, it's going to take some time, and the main source code which I got this code from. So Terraform, if you go to the Terraform AWS providers examples, and AKS getting started, you can find the details here. So if you go and look here, so this is the resource which I used actually, and the policy, Azure Room policy, these are provided by Terraform. So it's, and the, so usually we only need a few resources for creation, but I have customized it for my use case actually. And yeah, you will see here it's getting created, the ingress workstation. Okay, actually it's using a different workstation, but this is different from what I'm doing. So, but this is, you can always go to documentation and find these details. And the next part which I want to show you is, see here, this is the resource where I got the details. So scaling, update config. If you type for if you search for Google in Google for like AWS EKS node group and Terraform, you'll be able to, you can land here and find all the details here. And for any other resources, you can come here and look for the documentation. And coming to the next part, so yep. Okay, I want to tell you about. So there is a website where you can actually look for your IP address. Like, you always have issues. I know, and as a starter, as in my starting in career, so I already had like a lot of like confusion about IP address. Let me give an example and how it works. So if you go back to our code, in our variables, we have provided the IP addresses, right? So let's use this IP address and see how the IP address, like what IP addresses are I can use for using this subnet. So let's calculate, type on calculate, and you will be able to find. So this is the CIDR to IP4 conversion. So this is the range which I used in for the previous if you go here, this is for the VPC actually, and this is the range, and the mask could, this will be the default. And if you see here, come to the ending, so that we can use like 65,536 IP address in this range actually. And if you go back to the subnet, let me copy this, and this is very useful, and you will be able to understand very clearly how the IP addresses work. For this range, there are like two available hosts at 256, so you can use like 256 and vice versa for same. Uh, yeah, this is very good tip for you. You can, okay, you can see the resource has been added on successfully. So apply complete, and it has been. Let's go back to our AWS page and see if this got created. Let's refresh this. Okay, see, this is active, so the cluster has been created successfully, and the resource has been added. Compute networking, and the VPC has been created, and two subnets has been created, and one security group has been created in the service range. And we can also add add-ons, but right now I didn't do anything, but there is an option. We can use a third-party add-ons as well to this, so which is very useful. And let's go back and go here for the instances. It should create three of them. See here. So because we provided the max on demand was 3, so this will act as a kubectl server where usually um, which will this will act as a kubectl. So let's connect to the server, and we need to provision the kubectl now. So there is a URL for it. So this is where, so you can follow the same document here. So let's, for installing, uh, so if you can run this, you can find if kubectl has been installed. So there is nothing installed right now. And then if you come here and look for Linux, let's use the latest one. Let's see if that works. And then do curl, use the same commands, because the documentation is everywhere. It's like, it's very useful, and you can use the same. There will be no discrepancies. And then once it is created, the next option, this is optional, you can ignore it. And we run this. We give providing the permissions once it is good downloaded. And yeah, we provided the permissions for it, and then we create the binary. We provided, so we actually created a bin folder in the home, which is here, and then we copied the kubectl to bin. So actually, okay, and then exported the path. So then Let's run this command to see. Okay, so this actually initializes the file that is configured to open shell. So that's it's already done. So let's run the kubectl version. Okay, after successful installation of kubectl in the manage node, I came back here and I ran Terraform, just try to destroy everything which I created. So make sure to destroy it once you, if you're doing it for testing purpose or for training purpose, you just need to do this command, or else you will be getting charged with the AWS. So make sure to do that. So once we provide this your command, it will show up the resources which is going to be destroyed, and then ask for the confirmation at the end. So once we confirm, it's going to destroy everything like this. And also there is one more thing I forgot to tell you. I think I have initially when it got created, so it created three of them. I think I didn't explain it properly. So one of them would be manager node, and those out of three, the two are like the worker nodes. So yeah, that's all for today's video. So I hope you guys like my video. Please do like and subscribe my channel for more upcoming videos. I'll be doing more videos on AWS and Kubernetes with regarding to deployment and also containerization. And in the next video, I'll cover most topics about deployment, a sample deployment using EKS, a sample in Nginx application deployment, and also explain about containers and Docker setup and everything. Uh, See you guys in the next video. Bye. So see here, the kubectl is installed.